In this lesson, we're going to be looking at solving one-step equations with multiplication and division. I'm going to go ahead and have my same steps. Simplify, combining my like terms to moving variables to one side. Again, doesn't really apply with one-step equations. I'm going to determine the variable I need to isolate. I'm going to eliminate my terms by using the inverse or opposite operation. If I do an operation on one side, I have to do it on the other to keep it balanced. And then I'm going to check my work. So my first step, can't simplify anything. It's already as simple as it gets. I need to isolate my x, which means I need to eliminate the 7. While I look at 7 and x, there's no sign between them. And I always remember no sign means multiply, so the opposite, the inverse of multiply, is divide. So I divide both sides by 7. My 7s are going to cancel. And negative 21 divided by 7 is 3. And if you use the little mic dude, I have a negative and a positive. Those cancel out, which means my answer has to be negative. So I get x is equal to negative 3. Again, my last step, one of the most important, I want to check it. 7 times negative 3 equals negative 21. 7 times 3 is 21. A positive times a negative is a negative. Negative 21 equals negative 21. So that goes ahead and checks out. So I know I solved it correctly at this point. Okay, let's go ahead and look at our second example. I have negative 3x is equal to negative 27. I want to solve for x. I want to isolate it, get it all by itself there on the left side. So I need to get rid of the negative 3. Again, nothing between the negative 3 and x. Not saying x minus 3 because it's at the very front. So negative 3. I need to get rid of it. It's multiplying, so I divide again. My negative 3's are going to cancel out. I'm left with x. Negative 27, or 27 divided by 3 is 9. If I draw my little mic dude again, I have a negative and a negative, which leaves me with a positive. So my answer is positive 9. If I go over here and check it out, negative 3 times 9 should give me negative 27. 3 times 9 is 27. If I use my mic dude again, I have a negative and a positive, which means my answer is negative. Negative 27 equals negative 27. Okay, moving on to example 3. I have x over 6, and I know that my fraction bar means divide, so x divided by 6 is equal to negative 3. I want to isolate my x, so I have to get rid of the 6. I'm dividing, so the opposite is multiplying. So since that's written as a fraction, I always like to write what I'm multiplying by as a fraction. On the other side, negative 3 isn't written as a fraction, so I just might write times 6. On the left here, my 6's cancel. I'm left with x. And negative 3 times 6 is a negative 18. Again, negative and a positive leave me with a negative. So if I go and check, negative 18 divided by 6 should give me negative 3. 18 divided by 6 is 3. Negative and a positive leaves me with a negative, so negative 3 is equal to negative 3. So my answer checks out again. One more final practice problem here. X divided by negative 7 is equal to 2. I want to isolate the x, so I need to get rid of negative 7. Again, written as a fraction, so I write times 7 as negative 7 as a fraction. On the right it's not, so I leave it alone. My negative 7's are going to cancel out, and part of the reason for that is if we actually multiplied our fractions here, I go top times top, bottom times bottom. Negative 7 times x is negative 7x. 1 times negative 7 is negative 7. Negative 7 x divided by negative 7 leaves me with x. So the quick way of doing that is like I showed you there, where you just cross out the top and bottom. So I'm left with x. A positive times a negative is a negative, so negative 14. And if I go down here to check it, negative 14 divided by negative 7 gives me 2. Well, my negatives are going to cancel out. 14 divided by 7 is 2. 2 equals 2. And my problem checks out. All right, that's your lesson on one-step equations with multiplication and division.